Okay, so I'm gonna try to make this video short and brief so that you can understand this better. So basically, the first thing I want you to do before watching these videos is just probably stop here and then build something look like this. So basically, what you want to do is just take a carbon, use those short little things to connect the carbon, and then use 4 different small little things, different colors, and then link them and look something like this. So in order to make it easier when I'm doing the questions later, so this the purple is on top, the orange is on my right hand, again my right hand, and the green is on my left hand. Okay, so just build something like this, so when it's easier when I'm recording my screen, when I'm doing this, solving the problems, it's easier to understand. Okay, and then I also want you to build something like this. So basically this one would be a chair conformations of the cyclohexane. So basically what you want to do is take the 6 carbon, like the black one, and then link them together and make something look like this. Again, you have to link them, use a short one, don't use the long one. The long one is for double bond. Okay, use the short one. And the hydrogens, it's basically just the white one. You can just use a little thing that look like a mushroom. So you would link something look like this. Okay, and remember, when you building the chair conformations, the final structures must look something like this. So it must have 3 hydrogen atoms in axial positions on top, 3 in the bottom in axial positions, and equatorial. So again, okay, so right now I'm gonna try to explain with the chair conformations. So the chair conformation is basically it's look like a chair. If you look at this, if you look at it like this, it look like a chair, right? So I will draw it later, but it's basically look like a chair. So this is it look like a chair. If it's just the carbon itself, it look like a chair, right? It have 3 carbon on 3 hydrogen on top in axial positions, 3 in the bottom in axial positions, and all this around in equatorial. The equatorial is more stable than the axial. Reason why? So if you look at this molecules, all these little hydrogens here have a cloud of electrons around them. When they are in axial positions, their electron cloud are closer to each other, which means that they can interfere, which means that it's less stable. But if they are in equatorial positions, which is this position here, so on the side, equatorial, axial, equatorial. So when they're in equatorial positions, they are more stable. Why? Because in that positions, there's less interactions between that cloud of electrons with the other one, right? So if you see this one, let's say this one, right? You can see that this one have less interfering with other electrons around them, right? So equatorial more stable than axial. Remember that. Okay, so build this one. I'll just explain it later. So come back to this one. So basically, what we're gonna use is this. So what we're gonna use this is that, remember, when we're figuring out the RNS configurations, we are looking at it so that the lowest priority is away from us, right? So let's say in this molecules, this one have the lowest priority. So again, the white one, lowest priority. So when I try to figure out its configurations, I will look at that so that the hydrogens is away from me, right? So it's away from me right now, right? And then I will assign each one of these, like each one of these, one of the as one of the molecules that I'm gonna analyze in the questions, okay? And then I will explain that later. But basically, this is how I'm gonna look at it, right? So you go look at it this way, okay? Or it can be like this. But basically, how you look at it is so that the hydrogens is away from you. So this is how you look at it. This is how I look at it, okay? See? So the hydrogen is away from me, okay? Make sense? Okay. Okay, here we go. So let's just make this quick. So this is example that I take from the midterm of 2018, I believe. So if you want to take a look at it, it's gonna be from the midterm from 2018. So first we look at this position. So we have trans, right? Trans of this molecules. Okay, I'm just gonna use this thing. Give me one sec. So we are given these molecules and they are asking for us to draw 2 chair conformers of these molecules and identify which one will be more stable, right? So what I did first is basically draw the chair conformation itself. So if you can see here, this is going to be the chair conformation, how you're going to draw in exams, okay? And what I found easier to do, which is to kind of like label them with numbers. So you can see here, I label them with 1 and 2, right? So give me one sec here. So 1 and 2 here, okay? And you see that, right? And if you look at this, that's 1, that's 2, that's 1, that's 2, okay? So far so good. Hopefully you're catching it up. So if you look at your molecule set that you have here, okay? If they are in trans configurations, trans, it means that one is going up and one is going down. So something like this would be a trans conformations. If it's in cis, it means that are on the same side. Okay, so far so good. So because they are in the trans conformations, right? It means that two of them are both in axial positions, right? So right now I want you to take the molecule, the chain conformation that you have, and then look at it and see. So let's say if you look at it from up, look at it down from like, yeah. So you can see that one is going towards you and one is going away from you, right? So if you take a look at that, if you look at it from this angle, right? Look at it like from, if you're holding it face you, right? The 6 carbon face up to you. If it's in trans, it means that one is going up and one is going down, right? If one is going up and one is going down, it means that they are in trans configurations, right? So the first one I can draw, if they are in trans configurations, is basically this, right? So that would be that, right? Okay, so right now, what I want you to do after this is that basically take the hydrogens that you're having right now and change them with one of the new molecules, okay? One of the colors from the set that you have. So you can just change the 2 bromine that are the two, one of them is going towards you and one is going in the back. So they are both must be in axial positions, okay? So I want you to do that, and then right now I want you to flip the rings, okay? So flip the rings. So basically you will flip the rings. And right now, after you flip the rings, you can see that both bromines are now in equatorial positions. So if they are in equatorial position, it would be something like this, right? And remember, I tell you before, if they are in equatorial positions, it means what? It means that this position, this chain conformation is more stable, right? So this would be how you answer these questions. I will show you later when I flip the ring and how they change it. But yeah, basically that it will be the first one, okay? Second one here, okay. So right now, what I want you to do is basically take the one that I told you before, the one that have the carbon that linked to 4 different things on them, okay? And then basically, oh my god, no, I did it. Give me one sec here. Sorry, I just don't know if I put it correctly. Okay, so let's continue. So basically, when you're holding that thing in your hand, okay? So right now, let's see. So number 2 here, okay? So let's see number 2 here. Let's assign their priorities. So we know that chlorine is 17, right? So that would be 17. And okay, so the assign priorities is basically their atomic numbers, okay? So if you look at the atomic numbers on the periodic table, you can see it's chlorine is 17, I think so. Oxygen is 6, right? And then this here and that there, okay? This is a bit tricky here, focus. So that carbon right there, right? So that one is 6. That carbon, when it linked to oxygens, and if it's linked 2 times, right? So this is basically when you assign priority, that would count as 2. Sorry, it'll be 4. Sorry. So carbon will be 4. And if that would be count as 2, so it'll be 2, 6. Right? And then for that one, okay, so double bond will be count as 2. Okay, just remember that. Count as 2 because they have a double bond there. So 2, that will be there. Okay? So let's look at this one. So that one is carbon. So that'll be 6. Linked with chlorine. So that'll be 17, right? And then another oxygen here. So that will be... So sorry. I just keep writing this. Sorry. So that'll be 4. Sorry. So that'll be 6, right? So, sorry. 4, 17, 6. Okay? So if you compare this 2 number here, right? This one is lower than the 17. Okay, so which means that this one would have a lower priority than this one. So now when we assign priority, the chlorine would actually have the highest one, right? That will be number 1. Oxygens will be number 2, right? Because it's 6. 6, 7, and this is 4, right? So I'm just gonna start with this. So that will be 4, 4, and 6. Right? You can see that. Okay. So that would be 2, and then that one will be 3, right? Because 17 is larger than 6, and that will be 4. Okay. So after you assign priority, right now I want you to hold that molecules that I told you earlier on your hand. Okay. And remember this: after you build these molecules, the hydrogens will always be the one that you assign as the lowest priority. Okay. So if you rotate it so that it would look something like this. Okay, I will draw it here. So the white one, let's say this is white, okay? And then this is orange, right? And then that one in the back there is purple. And then the thing in the front is green, yeah. So this is what I hold in my hand right now, okay? And if you look at that, see? You can see that if you look at this and then that, right? It's kind of the same, right? So right now, what I want to do is basically assign this. So the white one will be number 4, right? The green one is going in the front. So that will be chlorine. So our chlorine is number 1 here. Okay? The purple one will be in the back. So that will be our hydrogens, oxygen. So that will be number 2 there. Right? The orange one will be our number 3. Okay? So right now, I want you to rotate it so that it's facing you. The hydrogen is in the back, and then the other one is facing you. So it would look something like this if you look at it from how I look at it right now. It should look at me. So this will be a carbon, okay? Carbon center. Oh, why is it like that? Oh, sorry. So this will be carbon centers, okay? I have the orange one, in the and then I have that one as purple here. And I have green here. Okay, and the back is the white one, which is the lowest priorities. Right now, you're assign priority. So you have green as number 1, 2 purple, 2 orange, 3. Right? So it was something like this, right? Again, I'm sorry, I'm just gonna use the different colors. So that would be that, right? And remember, if it's turning right, that will be what? R, right? If it's going the opposite way, which is counterclockwise, that will be S, right? So R and S, okay? Right, and then S is like left, to turn left. The right, it's to turning right, right? Steering wheels, okay? So our number 2 here will be R, okay? Okay, so after this, I'm gonna erase this, okay? So stop here if you want to, or I will just erase this, okay? 1, 2, 3, erase. Cut. Okay, so let's look at number 3 here. So 3 is this one, right? So that's number 3 here. So doing it again. So we assign chlorine as the first priorities, right? Because it's the highest one, it's 17. Oxygen here will be the second one, right? Obviously, because it's have 6, right? So now when you look at this, right, you look at this. This is what you're going to consider. This one linked to another chlorine and an oxygen. Okay, I'm just gonna, linked to another chlorine and an oxygen, right? So that down there linked to another chlorine and an oxygen. But that carbon right there linked to, actually, technically, it would link to 3 carbons, right? 3 carbons. Why? Because this one count as 2 carbons because they have a double bond there. So a double bond, they count as 2. This one right here will be count as 1. So that'll be C here. So just another here. And that will count as 2. Okay. So if you were to assign this, it would be 6, 6, 6. And then I guess you can take one and the one big out of will be 666. Yeah, it'll be 666 because they also have another carbon here. And then there's no hydrogens there. But this one, it would be chlorine. This is 17, right? 17. And then that one will be 6. Right, sorry. Oh, I keep forgetting. So that's sorry. So the thing before with carbon will be 4. Sorry, very sorry. I'm sorry. So 4, 4, 4. Right, because there's 2 carbon here, and that is 1 carbon. So it'll be 4, 4, 4. That will be 4, 17, and then 6, and then you can guess. Yeah, and then another 1 more carbon there. So that would be 4. Right. I keep forgetting. Yeah, sorry very much. So that would be that. Okay, so right now after you assign priority, you know that this one is higher, so this one will be number 3. Right, that one will be number 4. Okay, now take the molecules that I told you before and look at it. So your lowest priority is technically, if you look at it, so that if you look at it from this angle, let's see here. Yep, so this would be what you were looking at. So I'm gonna draw what I'm looking at right now. So what I'm holding it right now will be the white one on that one. The carbon centers here. The thing in the side is the purple one. The things in the front is an orange. And the thing in the back is the green one. Okay. So if I look at that, so that green will be number 2, right? Oxygen's in the front, that'll be number 1, right? That thing there, the purple one, will be the 3, right? So now you rotate it so that the hydrogens is in the back. So right now, what I'm looking at is looking something like this. So this is the main carbon, okay? The thing on top is the orange, okay? So orange here. And we have purple on the side. And another one green here, okay? So if you look at this, so orange have the number 1, so 1 here, right? Purple is 3, right? Green is 2, okay? So let's change the color. So if you look at this, there will be that, right? That, right? So that'll be raw, R, right? So that'll be R, okay? Right. Okay? So number 3 will be R, okay? So let's do this one quickly. So before you're doing this, remember this. E will be high, low, low, high. Okay? And this is a double bond here. Z, same dài. High, high, low, low. Okay? Double bond here. Okay. So if you look at number 2 here, right? This one will obviously have a higher one because sulfur have a higher atomic number than carbon. So that one obviously have a higher one, right? That will be low, okay? And if you look at this, it's really a giveaway because this chunky obviously have a higher priority. So that will be high and low. So number 2 here will be E, right? Okay, I'll erase this. So take it out, okay? I'll erase it. Cut. Next one, so number 4 here. So if you look at this side, that side. Sorry, I'm assuming that you know that. This side and this side, okay? This side right here will obviously have a lower one because it's less bulkier than this side, right? So if you were to assign priority, right, that one will be low and that one will be high, okay? Continue. So this side, if you look at this side, and then this side, right? So when you look at your priority, remember earlier? So that one, that carbon here, right? It's linked to 2 more hydrogens, right? And that another carbon. But this carbon here, it's linked to 1 hydrogen, but 2 carbon, right? So this one will be, if you were to write, it will be 4. Linked with 2, 4, so that'll be 4, 4, and then 1. But if you were to, this will be 4, 4, 1, 1. So obviously, the thing on top would have a higher priorities, right? So the thing on top have a higher priorities mean that they could be high and low. So if it's low, high, high, low, it would be E. So our 4 would be E. All right, so that will be A, okay? So okay, sorry, I'm just gonna, so and then yeah, so this one will be A. Okay. Okay, so before we go, I'm just gonna help you to understand what I was trying to say with the earlier, how I changed with the promean one. Okay, so if you look at the chair conformation, question number 1. Okay, so this is what we have, right? But then right now, I want to know how, when, let's say I want to kind of test, right? To test whether the bromine, how would it go? So if you look at this chair conformations, okay, they are trans dipromine, right? So trans diaxle would mean that they are both in this position. So that one right there and the lower one, or these two. So those be trans diaxle, okay? So right now I want to test, and I want to see if, or I should say, if I flip the ring, what position it will be, right? So I just gonna take this out, and let's say I take another one. Just take this one for now. It's easier. So this right here, right? So this one here would be in axle, okay? Because it's diaxle. And another one next to it, right? Because if you look at that, it will be, this is carbon number 1, and this is carbon number 2. Okay, so okay. That's right. Okay. See? So that makes sense. Okay. So if we look at the chair conformations, that bromine is going towards you, like this, like the questions, and that's going in the back. Okay. So right now I'm gonna teach you how to flip the rings. Okay. How you gonna flip the rings is basically you would take this one, you would basically flip, you would take that one, and then just kind of like push the other one around so that they're in these positions, right? So this one will be in both equatorial. Okay. So this one will be more stable, right? Because their cloud electron cannot interfere with the thing in these positions. Because right now, if say I'm gonna flip back, okay, I'm gonna flip it back. Let's see. Okay. So when I flip it back, the bromine here have a very large carbon electrons. They will interfere with these 2 hydrogens, right? See? Same with this bromine in the back. This carbon electron will interfere with this one. So if you were to want to, they ask for the most stable one, it will be the one that they are in both in equatorial positions, which is this one, right? If you flip the ring again, you flip is basically, okay, I'm gonna show you. Okay, so what I did is basically I flip like this, okay? And then you flip this in here, like all the, like just kind of like separate one by one, flip, and then I can flip them back, right?